In this video, we will see binary search functions. I will write iterative version as well as recursive version. So first of all, let us write a iterative version. Binary search, it should take a parameter that is array, and it's going to just access the elements. It's not going to modify them. So call by value is sufficient and the key that we want to search. Now for performing binary search, we need following variables: low, mid, and high. Low should be initialized with 0 and high should be initialized with length minus 1 because the last element is present at length. So length minus 1. So these are initialized. I will write return 0 to avoid this error. Then the procedure is using a loop while low is less than or equal to high. Find out mid. Mid is low plus high divided by 2. Then check if the key is same as A of mid. If it is same, then we got the element and return its index. The index is mid. Else if key is less than A of mid, then we will modify high value to mid minus 1. Else definitely it is on the right hand side, so we'll change low value to mid plus 1. That's all. In this loop, it will check for the element. If it is found, it will return its index. Otherwise, if it is outside the loop, means we should return minus 1, saying that the key element is not found. So this is the same code what we have discussed on whiteboard. Few changes are there like parameter and these low, mid and high, which I have declared them. Now let us call this function inside main function. So I will directly show its result. So I will use printf %d /n and I will call binary search function by passing array, and the key that I want to search is 5. Let us run this. I got the index 3. Yes, see, this is 0 and 1, 2, and this is 3. I will change the key value to be search. I will give the value as 2. Let us run this. This index is 0. Yes, correct. I'll give the key element as 10. 10 is not there in the array, so I should get index minus 1. Yes, index is minus 1. That is, key element is not found. I'll give the element as 15. Let us run. The element is not there, so it should return index minus 1. Yes, index is minus 1. So that's all with this binary search. Let us write a recursive binary search function which takes parameters low, high, and the key value. But here I will also pass an array. So let me write down the function name as bin search, bin search. It takes 3 parameters. First is an array, low, high, and the key value. These are the parameters we'll be passing. And here I will write down return minus 1 to avoid the error. Now inside the function we also need a mid. Then I will write on the procedure that we have seen. If low is less than or equal to high, then only we will check for the key. And the method for checking the key is first find out mid, that is mid is low plus high divided by 2. And check if key is equal to A of mid, the array middle location. If so, then return mid. Else, if key is less than A of mid, then we will check on the left hand side. So I will write return bin search. I will pass array A and low as it is. Instead of high, we will pass mid minus 1 and the key as it is. Else, we will return. Now we have to check on the right hand side, so I will say r bin search array as it is. Low, I will change it to mid plus 1 because we have to check on the right hand side. High as it is, and this is key. This is the recursive function for binary search. Now let us call this r binary search from the main function. I will change this r bin search. We have to pass array, so arr.a array. Then low is initially 0, definitely. Then high is arr's length. And the key that I want to search is 5. So I have sent the sufficient parameters for this r bin search. Let us run the program. Yes, we got the index 3. I'll change the key to 2 and run it. Yes, index is 0. It's working. I'll change the key to 9. 9 is not there, so I should get the index as minus 1. Yes, it is minus 1. So it's working. That's all with the binary search functions. I have shown you both iterative version as well as recursive versions. And you can debug these programs and check how the low and high values are changing and how it is finding calculating mid every time. So that's all in this video.